Hi guys, welcome back to the channel. In this video we are going to discuss about two things called preset and clear. So this is under called asynchronous inputs. So let's see what is meant by asynchronous inputs. So in the previous videos we have already discussed about SR, JK, D, T flip-flops. So we have a clock, we already know about that. So these are all inputs. If you observe in the first one SR, so SR, those two are known as synchronous inputs, and remaining that is clock, we already know about that. So remaining all these things are known as synchronous inputs. So let us first understand what is meant by synchronous inputs. For that I took the D flip-flop and I am passing clock, that is trained pulse of square waves. Square wave pulse I am passing into clock directly. So that you can observe that we have clock and one input and two outputs. So if you observe the output, that is corresponding to D. If you observe, we are already see all this discussion how to draw this timing diagram analysis with the help of the clock D, how we have to compare clock and D, how we have to generate output Q properly. We have discussed in the D flip-flop video. So this is basically nothing but when the clock pulse is going up, then output would be responding, and again the next rising clock edge only the output will be responding according to that. Means in these normal synchronous inputs we should understand that when only clock pulse is changing, that time only output will change. The output is corresponding or output is related directly with the clock pulse, that I can say in the synchronous inputs. Whereas in the asynchronous inputs we have two inputs called preset and clear. So let us understand what is meant by this. So I hope you might see this kind of circuit diagrams or the block diagrams of a 7474 IC chip in your labs or somewhere else. So basically if you observe here we have two D flip-flops here inside that. So if you observe we have called something called reset and set. So it is also known as preset and clear as well because both are same. So the name itself indicates that preset means it becomes 1 as output. Clear means what? It clears and all will be clear and final output would be 0. So that is the thing that I can say. So these are the things that is present in this situation. So in this also we have a clear one. This is IC chip, that is 7476. So we have a clear thing. So the position might be changing. So but all things would be the same. Its functionality would be the same. It will be cleared and it will be resetted or something else like that. But the position would be changing for the different IC chips according to our requirement. But the thing it done is same. So if you observe, this is the thing that I am showing here with the help of D flip-flop. If preset is 1, clear is 0, then you can observe clear domination of preset. So in this situation we are going to have output Q is equals to 1 irrespective of the clock. So I am mentioning again that is irrespective of clock. That means if clock is anything, that clock and D will not be corresponding to each other to produce the output. Q is always 1 with the help of preset is equals to 1. So this is the main usage of using the preset and clear inputs, known as asynchronous inputs. And in the second scenario, if you observe, we have preset is equals to 0 and clear is equals to 1. In this we have clear domination of clear. So in this position also, what is meant by clear? The name itself suggests the output Q is equals to 0. So as these are normal inputs, preset and clear, we are going to consider them as active high inputs. So in the same way we have something called active low inputs. So active low inputs means nothing but just the opposite things or the bar. So if you observe the definition, active low inputs means the function is activated when input signal is low instead of 1. So if you observe SR, active high inputs, those are preset and clear, normal preset and clear, those are active high inputs. But if you just have the opposite thing, that is S bar, R bar, those are known as active low inputs, or preset and clear bars, that is active low inputs. So instead of representing that bars, we can represent in the normal format S and R, and we can say them as active low inputs. So this is the asynchronous inputs only, these are, but we have called something active low inputs because we can represent that preset bar or clear bar, or simply we can represent them as preset and clear, and we can mention that those are active low inputs. Both the representations are correct. We somewhat discussed about these active low inputs in the video called NAND latch. So you can check out that video. I am giving that video in the description box. So by seeing this with the help of input, output, preset, clear, we have some combinations like this kind. So we are going to analyze the truth table and we are going to judge the inputs and outputs so that we can have a clear vision for that. So if you observe here, I have took in this case the active high inputs, means the preset means both are the actual things, that is preset and clear. So the first situation I took preset and clear as 0. So now it behaves as normal D flip flop. So we have already discussed about normal D flip flop. So when if you observe there, when clock is 0, it will not work. It means the previous state would be recovered. That is Qn plus 1 is equals to Qn. Then preset and clear are 0. So normal D flip flop. When clock is high, you can also observe preset and clear are zeros over there in the truth table. Then the D will be same as the Qn plus 1. The next case, if you consider when clear is 1 or the preset is 1, the main usage for this is to reset or set the output. That is the main thing that you can see over there. So whatever may be the input D, the correspondingly it will be responding. So if you observe the first one means there. So there you can see clear is high first. So preset is 0, clear is 1 there. So for that we have already understood that when clear is 1, whole output would be dominated as 0. So you can see whatever may be the D is don't care. Qn plus 1 is 0. So the next case is preset is 1, clear is 0. So it is just opposite thing that preset is dominating here. So whole output would be 1. So in the last case, if we observe, the preset and clear are 1 1 both. So in this case, it will be an invalid state. So we should not pass at a time the preset and clear as 1 1. So now I am going to pass in the same way the active low inputs, means they are just exactly opposite of the inputs. So first if you see the preset bar and clear bar, so you can just relate them as opposite things. So first if you observe, we are going to check that first if you pass preset and clear as 0 0, after passing 0 0 it again becomes 1 1. So again we have discussed in the previous case only when preset and clear are 1 1, the output would be invalid. We have already discussed that. So when you pass preset and clear as 0 1, so just invert them. Here preset is 1 and clear is 0. So as preset is high, output would be high. If you observe the inside the blue box only, we have next case as preset is 1, clear is 0. So invert both of them. Now it becomes preset as 0, clear as 1. So output would be cleared like that. Just invert them, that's it. In the same way, if you pass according to the clockwise, means if you send preset and clear as 1 1, after passing into that D flip flop, it again becomes 0 0 because we are inverting them. So that we are going to have preset and clear as 1 1 for the normal performance of the D flip flop. So if you see clock as 0, it will retain its previous state. If clock is 1, then it will have according to the D flip flop input and clock, it will combinedly have output. Means D is equals to QA plus 1. So in the previous videos, we have already discussed about how we have to build or how we have to draw the circuit diagram of SR flip flop, D, JK, all we have discussed there. In this video, we are just going to add the preset and clear inputs to the circuit diagram, that's it. So just starting with the SR flip flop. So this is the block diagram of SR flip flop and this is the circuit diagram SR flip flop. Now we are going to add the preset and clear inputs to this and we are going to check or verify the circuit. So this is the, if you observe clearly, I have applied preset and clear to the SR flip flop now. So these are active low inputs, you can see there. Now I have to draw the circuit diagram, but a little bit changes. It's not much important to be remember this one, but it is very important, not important. It's just a better thing to know about this. Because we should know just functionality of preset and clear just for the understanding purpose. But the circuit diagram, they might not be asked in your university exams or somewhere else. So if you observe, all things would be the same, but you have a preset bar that is in the green color that is attached with the two NAND gates, that is going in the R NAND gate and that is the directly passing as the first one, means second one, that is giving directly as output Q. There we are passing preset and clear we are passing in the first one, means where there is as passing and it is where there is Q bar is producing. There in that two NAND gates we are going to pass the clear bar. So this is the circuit diagram of SR flip flop including preset and clears. So in this only, what if you want the active high inputs? So in the previous case we have directly took the inversion, that is preset bar, clear bar. Now if you want the active high inputs, means the normal inputs, again you are going to add a NOT gate like they are shown there. That's it, it becomes our normal active high inputs. So now we are going to construct the D flip flop. If you observe, that D flip flop is also just exactly a same thing, but it little bit change of SR flip flop. So combine both of SR inputs and join a NOT gate for the R input. So it becomes like that. You are only sending a D and just D bar to the R input. Remaining all things would be same. This is the D flip flop. Now we are going to apply the preset and clear for this D flip flop and we are going to verify the circuit. So this is the circuit diagram after applying the preset and clear active low inputs to the D flip flop directly. You can also observe there. And now we are going to pass in the same way as we saw in the previous thing, that is in the SR flip-flop. The same way we are going to attach the preset and clears to that. So preset is attached to two NAND gates, that is cross coupled, means the one is cross coupled producing Q, and next one is for R. So R means your D bar here, I can say. So clear is attaching to the Q bar producing NAND gate and directly to the D passing directly. So you can check like relate or something, have some logic in your mind, and you can simply relate or remember the circuit. Now we are going to construct the JK flip-flop with the help of the active low inputs also. So in the previous video we have already discussed about JK flip-flop and its circuit diagram. So this is the JK flip-flop circuit diagram using the NAND gates. So we also already covered about NAND gate implementation and the NOR gate implementation also. But in this video we are going to just see with the help of preset and clear this NAND gate implementation. So just think the same thing, but we are going to have another things that called J, K, and J NAND gate is connected to the Q bar and K NAND gate is connected to the Q. Remaining thing will be cross coupled the same as the XR means SR flip-flop. So the next thing is also same. If you observe, the green line is preset bar and the red line is clear bar. So the same way we are going to attach in this also. So the Q directly producing for that one connection and the K passing is for that one connection. That is, you can see this is just simply a cross coupled connection. So first we have one cross coupled connection for the first two, next cross coupled connection for this next two, the red line and green line. So you can simply relate for these three because it's just simple cross coupled, right? So passing J directly one their connection and directly passing Q bar there is one connection, that's it. So this is also active low inputs. If you want active high inputs, just invert with the help of NOT gate. So why asynchronous inputs? So now you might get a doubt, okay, I understood clear and preset inputs. Then where we are going to use these inputs and why we are requiring that inputs? Suppose assume we have a counter. So in the upcoming video we have a detailed discussion on counters, but just understand it is a cascaded things of the flip-flops only. So in this thing I have two D flip-flops. So you can see I am giving a same clock. So first of all, after connecting like that, just switch on the power. Then what will be our outputs directly at the first time? We don't know that. So it will be some random outputs. So we don't want that. If you want to start all with the 1 0 or all, if you want to start all with a 1, then situations what you will do. So that is the same thing that is written down only. All the random instead of having all the random inputs at the starting, we are going to have all of them as 1, all of them as 0 using clear and preset. So let's see the circuit diagram for that also. This is the thing that I am saying about. You are going to connect the clear and preset like this. So up and down, it's not a problem, but you are going to connect both of them. You can connect preset up, you can connect clear down, that is your wish, but you have to represent both of them. So using preset and clear, you are going to manipulate the outputs. So let's see how to do that. Suppose if you want to initialize all the outputs in this counter with the 0, then you are going to have the preset as 0, clear as 1. This resets the all flip-flops at a time to 0 because so the clock pulse and D sometimes may not be same. So that is the situation. Then this clear input is used to have or to take control for the all flip-flops at a time to become all inputs or outputs as 0. So this importance will be understanding in more upcoming videos in the counter series. And vice versa also you can do that. If you want all the outputs at a time, the first stage or the middle stage or in between, if you want any of the output would be having initialized with 1, just do preset as 1, clear as 0. That becomes our whole outputs or all flip-flops are initialized outputs to 1. I hope you understood this video. Thanks for watching up to now.